Okay, we're going to start this next video here. I'm hoping to kind of finish up 3.4 and 3.5. We're on an outlier. So an outlier is an extremely high or an extremely low data value when compared to the rest of the data values. So we saw an example with like this example here in problem 17. With this hurricane had $81 billion, and that's way above what some of these other values were. Okay, and so I kind of tend to think that that's an outlier. Okay, we'll check that. As a note, when performing any type of data analysis, we should always check for outliers. Okay, and these values can strongly affect the mean and the standard deviation of a variable. Okay, we've already seen how in the case of the standard deviation, how when you include a data value, that was the marathon running one. How like if I were to include the sixth running time, which is 26.2 miles or whatever, that value is way above what was normally done there during the week. So that value would have a serious impact over the mean and the standard deviation. In fact, I think it was the standard deviation was like 3 units more than what it normally would have been. Okay, so the first thing that we need to do when we check for outliers is we need to determine the quartiles. Okay, the first quartile and the third quartile. And then compute the interquartile range. That's where we take the third quartile minus the first quartile. Okay, and then we need to determine the fences. The fences serve as cutoff points for determining outliers. Okay, and the lower fence, which we're going to call LF, is given by LF equals Q sub 1 minus 1.5 times the interquartile range. Okay, and the upper fence, which we're going to call UF, is given by the third quartile plus 1.5 times the interquartile range. Okay, and step 4, if a data value is less than the lower fence or greater than the upper fence, is considered an outlier. Okay, so these are kind of like boundaries that we're going to set there. Problem 18 is we're going to check the data in question 17 for any outliers. Okay, so question 17 was the hurricane damage costs problem. So I need to compute the fences, and the first and third quartiles were ones that I've already found here is 3.4 and 15, and okay, so to find the lower fence, I need to take 3.4 minus 1.5 times the interquartile range was 11.6 then in that problem. Okay, so when I enter that in the calculator, let's see here, we got 3.4 minus 1.5 times 11.6. I'm getting negative 14, okay, as the lower fence. And so the upper fence, I do the same thing then, where I take the third quartile, which is 15, plus 1.5 times the interquartile range, 11.6, and if I just quick enter that in, I get 32.4. Okay, so negative 14 to 32.4 would be cutoff points. And when I look at the data set here, so of course I didn't have any negative numbers, right? And 32.4 is the upper fence. Okay, so 81 is the only value that's outside of the fences. The hurricane damage cost of $81 billion is an outlier, and that was Hurricane Katrina, of course. Okay. Another definition. So the 5-number summary of a of a data set consists of the smallest data value, the 3 quartiles, and the largest data value. Okay. Another definition, a box plot, or sometimes we call it a box and whisker plot, is a way to graph quantitative data using the quartiles in our data set. The steps that we will use to draw a box plot are given here. So step 1, we need to determine the 5-number summary. And then step 2, we need to determine the fences. Okay, step 3, draw a horizontal scale to include the smallest and largest data values. Okay. Above the scale, you're going to draw a box from the first quartile to the third quartile. Then you're going to draw a vertical line in the box at the median. Okay. Step 5, draw a horizontal line at the middle of the box from the first quartile to the smallest data value that is larger than the lower fence. Then you're going to draw a horizontal line at the median, or at the middle of the box from the third quartile to the largest data value that is smaller than the upper fence. These lines are called whiskers. Okay. Step 6, any data value that is less than the lower fence or greater than the upper fence are called outliers and should be marked with a point or an asterisk. Okay. One of the things that we talked about is distribution shapes, and you can determine the distribution shape from a box plot. So step 1, if the median is near the center of the box and each horizontal line is of approximately equal length, then the distribution is roughly symmetric. Okay, now roughly symmetric does not mean bell-shaped. Okay, it usually does. Okay, but it could mean uniform. Okay, that's the same on both sides, symmetric. So all we know is that it's roughly symmetric. Okay. Step 2, if the median is to the left of the center of the box or the right line is substantially longer than the left line, if either one of those two things happen, then you can say that the distribution is skewed to the right. Okay. And then step 3, if the median is to the right of the center of the box, or the left line is substantially longer than the right line, if either one of those two things happen, then you can say that the distribution is skewed to the left. There's a note, identifying the shape of a distribution from a box plot or from a histogram, for that matter, is subjective. Okay, be sure to support your opinion when you mention the shape of a distribution. Okay, so let's look at problem 19. Where it says a box plot is drawn to represent each data set in problem 16 and 17. Okay, so we're going to comment on the shape of the distribution. Well, let's see here. So the first one, problem 16, is where we're looking at the alcohol percent levels in the 22 randomly selected beers. Okay, so I made a box plot. Here's my 5-number summary. And of course, the box needs to be above the scale, and each whisker is drawn there in the center of the box. Okay, now how would I classify the shape of this distribution? Well, it's like when I look at this box plot, it looks like the median, the vertical line there, is near the center of the box. It's a little to the right. Okay. Each line looks to be of approximately equal length. Okay, so I would say that the distribution would be roughly symmetric, maybe slightly skewed to the left. Okay, since the median is near the right side of the box. Okay, is skewed to the left. So in any case, you don't have like a perfect symmetric distribution. You get something that could arguably be called skewed to the left. Okay. Now in this second problem, in problem 17, we looked at the hurricane damage costs. Okay, and so here they are, and The 5-number summary is shown there. So again, to get the 5 numbers, I need to take the smallest value, which is 2.3, then the 3 quartiles, which is 3.4, 7.0, I've already got the 3 quartiles, and 15, and then the largest value, which is 81. Okay, now the 81 was considered an outlier. Okay, we've already said that earlier here, and so I'm on step 5, where I'm going to draw a horizontal line in the middle of the box from the first quartile to the smallest value that is larger than the lower fence. Okay, I did that. Okay. By the way, I don't have any negative numbers, right? So I can go to 2.3 is the smallest data value given in the data set. And then I'm supposed to draw a horizontal line at the middle of the box from the third quartile to the largest data value that is smaller than the upper fence. Okay, so the upper fence is something I haven't, well, it's 32.4, right? So the smallest value that is less than the upper fence is 26.5. Okay, if we look at our data set here, 26.5 would be the smallest value less than the upper fence. So that's where I need to end my right whisker. Okay, and then I'm on step 6. So any values that are less than the lower fence or greater than the upper fence are called outliers and should be marked with a point or an asterisk. Okay, so I'd want an asterisk or a point at $81 billion. Okay, since Hurricane Katrina was an outlier for that data set. Okay, so this would be my completed box plot for the distribution that was the hurricane damage costs. And you know, like any other graph, it's important to have the labels there, and that. Okay, and let's see. If I comment on the shape of this distribution, I would call this skewed to the right. There's really no question about it. If the median is to the left of the center of the box, and that's what I see, or the right line is substantially longer than the left line. So here's the right line, here's the left line. The right line is substantially longer than the left line. Now, if either one of those two things happen, I can call this skewed to the right. Okay, the fact that both happen and I've got an outlier on the right side means that this is a no doubt skewed to the right distribution. There's no other classification that would work. Okay, so skewed to the right would be my answer there. Okay, why don't I go ahead and stop the video here, and I'll do the last problem in the next video.